Hello everyone, my name is Ram Kiranganathan and I'm thrilled to be speaking with you today about Data Lakehouse adoption. With over 15 years of experience at Systix Solutions, working in data management and analytics, I've seen firsthand the tremendous value that a properly implemented Data Lakehouse can bring to organizations of all sizes and industries. This experience has given me a unique perspective on the challenges and opportunities involved in adopting a Data Lakehouse approach, and I'm really excited to share my insights with you all today. Thank you for joining me today, and I look forward to our discussion. In today's session, the first part of the session will discuss the case for data lakehouses. Next, we will explore data lakehouse adoption strategies, including best practices for planning and implementing a data lakehouse, and tips for ensuring a successful transition. After that, we will look at data lakehouse migration scope, including things to consider and how to manage the migration process to minimize disruptions. We'll then understand how DBShift, our unique Systix Unix approach, can help organizations de-risk and accelerate their data lakehouse migration. In the case study section, we'll take a closer look at a real-world example of a successful modernization done through DBShift. Finally, we'll wrap with a Q&A session, giving you the opportunity to ask any questions you may have. A brief introduction about Systix Solutions. We are a modern analytics consulting firm, and we specialize in data management and analytics products and services. We are founded in 1993, and we have grown to over 350 global consultants and 400 plus customers. Our mission always has been to enable business transformation through the intelligent application of data. Our key focus areas include data management, analytics, and insights through core and advanced analytics, including machine learning, cloud modernization, and building intelligent applications. Overall, we have been a trusted partner for several organizations looking to harness the power of data to drive business success, and our team of experienced consultants can help you transform your business operations and unlock new opportunities for growth. So let's dive right into the session today. We are all familiar with the data warehouse. A data warehouse follows what we call as a top-down approach because of its model-first design. Now, in a top-down approach, the process begins by understanding the business requirements, the business problems that we are trying to solve, and the analytics dashboards and/or reports required to accomplish the business goals. This involves identifying the business dimensions, key performance indicators, and metrics that are critical to providing insights necessary to meet the business goals. Based on this understanding, the data warehouse schema and the model are created. Now, once the schema and model are created, the focus then shifts to the ETL process. The data is extracted from the source systems and transformed into the desired format and then loaded into the data warehouse. Once the data is available in the data warehouse, reports and dashboards are built based on specializations and specifications and delivered to the business users. While this approach works great, there are some disadvantages to it, which will be evident once we understand the bottom-up approach. Now, in a data lake, it allows organizations to store large volumes of structured, semi-structured, and unstructured data in a centralized location without the need for predefined schemas. The data is ingested into the data lake in its raw form and is transformed later as needed for analysis and reporting. In complete contrast to a top-down approach where the schema is defined first, the bottom-up approach allows organizations to store and process large volumes of raw data in a flexible and scalable manner. Now, this bottom-up approach provides the ability to ask more of your data since the data lake has all the information needed without any constraints. However, it also requires more advanced data management and processing techniques to ensure that the data is properly curated and transformed when needed. To summarize, the bottom-up approach differs from the top-down approach by not limiting the data elements available for analysis based on a business requirement. This is partially made possible because of the cost of storing and processing raw data in a data lake is way cheaper compared to a data warehouse. While augmenting a data warehouse with a data lake satisfies an organization's information needs, there are tons of benefits if these two environments could be combined into what we call as a data lakehouse. It can reduce costs by avoiding data silos and data transfer processes between the data warehouse and the data lake. It improves reliability by eliminating data transfers, thereby reducing the risk of quality issues and ensuring data consistency. Data duplications are avoided by combining the data warehouse and data lake. And a data lakehouse supports all different kinds of data personas, either it be people consuming dashboards, power users, business analysts, data scientists, and whatnot. It also provides a common metadata layer that can be used to apply fine-grained data governance policies. It also helps to treat data as a product and be grouped into domains to support a data mesh kind of architecture. Finally, the data lakehouse helps to keep data organized and free from the chaos of data swamps, which are unstructured data lakes that can become difficult to manage over time. Now we have seen what are the benefits of a data lakehouse. How are enterprises adopting the data lakehouse? I would like to walk you through the results of the research conducted by Ventana Research in 2022 on the topic Data Lakes Dynamic Insights, aimed to understand the current state and future trends in data lakehouse adoption. The research involved a survey of 500 professionals across a range of industries, roles, and geographies. Here are the key findings of the research. The key stats from the research to focus on are: number one, the adoption of data lakehouses is increasing rapidly, with 91% of organizations already using data lakes for analytics. More importantly, 23% of the companies have migrated their data warehouse to a data lakehouse. Now, while data lakehouses offer several benefits, organizations do face challenges in adopting data lakehouses. One way to mitigate the risk is to follow a migration methodology. The methodology starts with a discovery phase that analyzes the current data landscape to come up with a specific multi-phased adoption roadmap. Now then comes the analysis and design phase, which takes complete inventory of objects that need to be migrated and performs structural mappings between source and target systems. Then comes the migration and the re-engineering phase. Now in this phase, the majority of the tasks required for data lakehouse adoption happens. This typically involves data structure migration, ETL SQL migration, dashboards, visualizations migration, for example, Tableau or Power BI, Python notebooks migration, and even in some of the dashboards, custom SQLs are used, and those need to be migrated as well. The final phase is the deploy phase, in which we completely test and validate objects migrated to a data lakehouse. And then we finally deploy the data lakehouse to production and monitor its usage. We'll look at each of these individual phases in detail and how our DBShift solution can de-risk this adoption through automation and acceleration. Now, the discovery phase is a process that helps organizations plan and implement a successful adoption of data lakehouse. The overall goal of this phase is to come up with a strategy for data lakehouse adoption and is built around 4 pillars, namely data, technology, policy, and skill. Under the data pillar, the organization studies its data inventory, data touchpoints, and frequency and mechanisms of data usage. This helps them understand the data assets they have and how they can use them to derive business value. Under the technology pillar, the organization performs a technology assessment and comes up with a future state architecture for the data lakehouse. This ensures that the organization has the right technology infrastructure in place to support the data lakehouse adoption. Under the policy pillar, the organization studies its organizational culture, methodology, and standards to ensure that the data lakehouse adoption aligns with its policies and processes. The organization also identifies success metrics to measure the impact of the data lakehouse adoption. Finally, under the skill pillar, the organization performs a data literacy assessment to identify training needs and ensure that its people have the necessary skills to derive business value from the data lakehouse adoption. The key outcome of this discovery phase is a multi-phased, milestones-based implementation roadmap, along with technology platforms and data literacy plan to equip different data personas with required skills. Then comes the migration phase. Now, irrespective of the data lakehouse adoption strategy, which is either to replace the data warehouse or to augment the data warehouse with a data lakehouse, you might have to deal with one or two or all of the work streams listed here. At the core is the actual data structures and data migrations. From the data warehouse to the data lakehouse platform, data structures and historical data have to be migrated. Now, there are touch points on either side of the data warehouse which need to be migrated as well. On the left-hand side, we have what we call as enterprise ETL or extract, transform, and load processes or SQL processes that bring in data into the data warehouse. On the right-hand side, we have the consumption of the data in the data warehouse through analytics or visualization or dashboard platforms, either using out-of-the-box features or using custom SQL to extract data from the data warehouse. Now, these are the three work streams that need to be handled as part of this data lakehouse adoption. Now, the suggested approach is to have a multi-phase migration plan and have the focus on data migration during the initial phases and to deal with the touchpoint platforms in future phases. In either adoption strategies, either to augment or to replace the data warehouse, we have to deal with the migration of these work streams and perform detailed validation as well. Now, let's take a closer look at each of these work streams. Now, the data migration workstream involves the migration of database objects, including tables, views, stored procedures, functions, etc., from a traditional data warehouse platform like Netezza or Teradata to a modern data lakehouse platform like Dremio. In addition to the data structure migration, historical data has to be loaded into the data lakehouse and validated. Based on the complexity of the data warehouse, the volume of data, we might have to do repeated migrations or phased migrations. And at every point, we have to validate the migrated data. Now, in addition to the automated migration following the forklift approach, we look at specific areas of the data lakehouse that can be re-engineered to take full advantage of the features that a data lakehouse platform like Dremio has to offer. This is called as a re-engineering phase. There are many data validation strategies that can be applied to different areas of the data warehouse. Starting from a simple row count based validation, we can go all the way up to a complete 100% validation of every single row and every single column. Now, migrating data structures and historical data from a data warehouse to a data lakehouse can be a complex process that poses several challenges. And here are some of the key challenges. Data warehouses and data lakehouses have different data structures and storage formats. Data warehouse data is usually structured, while data lakehouse data is unstructured. This means that the data must be transformed and restructured to fit the new environment. Data warehouses often store a large amount of data, and transferring this volume of data to a data lakehouse can be a time-consuming and resource-intensive process. It's important to have a plan in place to manage the transfer of large volumes of data. Ensuring the security of sensitive data during migration process is also critical. Repeated data validations have to be performed to ensure the quality of data migrated to the data lakehouse. Now, just to give you a sense of the complexity involved in the data migration, I would like to take a scenario where, for example, if you are migrating from a Teradata data warehouse to a Dremio data lakehouse platform. Now, there are well over 1,600 built-in methods and operators in Teradata which need to be migrated to a platform like Dremio, of which more than 50% are not directly mapped to the Dremio platform. There are about 22 data types in Teradata compared to almost close to 10 data types in Dremio. So let me take a slight detour and show you the data type mappings between the two platforms. This is a Teradata to Dremio mapping of data types. As you can see, there are certain data types which are not readily available, for example, graphic. Same thing with the built-in functions. There are well over 300 plus functions based on the version of Teradata that you're using that need to be mapped or converted to Dremio. Some of these functions are ANSI standard. They can be used as is, and Dremio also does a fabulous job in making sure it's compatible. But there are Teradata specific functions which need to be migrated as well. Very quickly, I'll just show you the interface of
Ramki?
Yeah.
I think your slides might be a little stuck. Do you want to refresh your screen share? We're stuck on the data migration slide that talks about data validation types and data structure and supporting.
Got it. Thanks for letting me know.
Thanks.
Let me stop sharing and reshare again.
Yep, no worries. Now we have it. Now we have DBShift, and we can see step 1, step 2, step 3.
Awesome.
So we can see your full screen now.
Perfect.
Oh, we couldn't see the data mappings from Teradata to Dremio either.
Sorry about that. Let me try it one more time.
There you go. Yep, we see your editor now. Yep.
So this was what I was talking about, the data type mappings between Teradata and Dremio. And here are the functions, about 330 functions that need to be migrated to Dremio. Right? And I was about to go into our DBShift platform. So very quickly, I'm going to show you, let's say I, as an analyst, I have a bunch of SQL statements in Teradata that I need to migrate to Dremio. So I use the platform and I have a bunch of SQLs that I can upload. And it gives you complete flexibility in terms of doing migration of all these SQL statements in one shot, or you can pick and choose what you want to migrate. Let me take a brief moment to show you some of the SQLs, and the differences between Teradata and Dremio are highlighted here. Like, you can directly do data manipulations in Teradata, which need to be converted to a Dremio format. More importantly, I want to show you the stored procedures, and stored procedures are not readily mapped, readily available in Dremio. Like even a simple procedure like this in Teradata, and companies who have been using Teradata have invested heavily on procedures. So even things like that, you can actually use the platform to convert to Dremio. And in this case, it has to be converted to a user-defined function using a combination of Python and Java. Right? Now, in addition to converting these SQL statements and procedures, the data validation, as I was talking about, all the converted queries you can validate in one shot in a unified interface here, and you can choose what kind of data validations you want to perform. So I just wanted to quickly show you this, the interface as well. Let me just jump right back into the presentation. So that's about the data migration. So in the ETL or SQL migration phase, we migrate all of the touch points that feed data into the data warehouse and rewire them to the data lakehouse. There are two different approaches that are possible. The first approach is where the ETL platform stays as is, in which case the ETL processes in that platform have to be rewired and changed to point to the data lakehouse. Now, in the second approach, the modernization of ETL platform is involved. Like for example, you might decide to move from SQL Server integration services to Amazon Glue or Matillion, in which case a complete reengineering is required. Also, as stated in the previous data migration phase, repeated data validations have to be performed on these ETL processes as well. So individual ETL processes have to be run on similar environments on the data warehouse as well as in the data lakehouse, and the results have to be compared. And the same is the case with analytics migration as well. So you might have your reports and dashboards in Power BI and decide to stick with Power BI, in which case all those dashboards and reports need to be rewired to data lakehouse and validated. Or you can perform modernization. You can decide to move from, for example, MicroStrategy to Power BI platforms as well. Now, the simple task of rewiring it can be daunting because there are thousands and thousands of reports. In one of our migration, we had about 30,000 plus dashboards and reports that was in MicroStrategy, right? So rewiring each of these dashboards and validating them can be a daunting process for you, right? So that's where the DBShift comes in. Now, as you can see, all the three migration work streams, the data migration, the ETL or SQL migration, and analytics migration, involves a lot of effort, a lot of skills, and it has its own risks and challenges. Now, Systec's migration accelerator solution, DBShift, is a framework which can reduce these risks through automation and acceleration. And DBShift can automatically map the data structures, perform the data migration, and also automate and accelerate the migration of the other two work streams as well. Now, just to pause here, and I will show you if we have to migrate from a platform like Informatica to, for example, Glue. So I have a sample set of Informatica processes here, and of course, these processes are specific to the ETL platforms that you have. And in Informatica, you have the concept of mapping sessions and sources and targets and workflows. Now, in the case of rewiring your ETL processes in Informatica to a data lakehouse, you can just pick and choose your source and target connections to point to the data lakehouse and validate them. In the case of complete reengineering, you can actually choose the processes that you want, and you can actually choose your target platform that you want to migrate to. But as you can see, some of these processes are really complicated. When you're transforming data and loading it into the data warehouse. So jumping right back to the presentation. So not only DBShift can automate the data structure, data migration, ETL, and reports migration, it can also automate the data validation process as well. Right, so that's the power of DBShift. Right. Overall, we have seen that we can achieve about 70% automation through the DBShift platform, and I will illustrate that with a case study here. And before that, very quickly, the benefits, the business values of using DBShift. Right. Cost savings, DBShift can help reduce modernization costs up to 70%. Speed of modernization, it can reduce the effort by at least 50% through automation. And it's completely flexible. It can be easily customized to handle special migration requirements, allowing for more flexibility in the modernization process. It has monitoring dashboards and reports that you can clearly use to figure out the progress of the migration, which can improve project management and reduce uncertainty. Finally, reliability. Cost and effort reduction without reliability is, of course, no use. DBShift is based on our proven migration methodology and our skills, which completely de-risks and accelerates your modernization journey. Now, with respect to a case study, we used DBShift to migrate or modernize one of a major insurance provider in North America. This multi-line insurer faced two major challenges. One was the modernization of their end-of-life data warehouse, and the second was modernizing their data wrangling scripts from SAS to Alteryx. They used Systech DBShift to accelerate the migration. Just to give you a sense for the migration effort, we had about 3,000 processes in Informatica that we migrated in about 4 weeks. And so this gave them a lot of opportunity to cut down their migration costs and also focus more on how to use the insights derived from a modern platform. So that's all, folks. Thank you for attending this session on Data Lakehouse adoption. I hope you found this information and insights shared to be helpful in your journey towards modernizing your data management practices. If you have any further questions or would like to discuss how DBShift can help you achieve your data management goals, please feel free to reach out to us using this contact info provided on this slide. Thank you once again for your time and attention.